Hello everyone, welcome to my YouTube channel. So in this video, we are going to learn about scalability. But before diving into scalability, let's first try to understand how a simple web request works. So suppose we have a user which could be on a mobile applications or on a desktop application and it wants to visit a website say google.com. So first the request will go to the DNS server. From DNS server it will fetch the IP. This IP will be of a particular web server. So the request goes to that web server and depending on the use case, it will read data or write data to or from the database and ultimately it will return the response back to the user in the form of HTML, JavaScript or some JSON. So this is fine. This is how a simple web request works. So suppose you have a website and initially there were not much users and this approach works fine. Later on, your website became popular and this web server is not able to handle so much requests. So what do we do now? So this is the time to scale the system. We have two options here. First is vertical scaling or we also call it scaling up. So in this what we do, we make this web server more powerful. By more powerful, I mean we will increase the RAM capacity, we will change the CPU processor, we will have a more powerful CPU processors. So in this way, we are basically scaling up the system and then it will be able to handle more requests because the web server became more powerful. It is simple and straightforward. But the biggest problem with this is there is a hard limit on how much storage you can have. Like you can't have an unlimited RAM or as a processor or something like that. So this has the biggest drawback. So what we do now? So second option is horizontal scaling. So in horizontal scaling, what we do is we add more web servers. Okay, we had initially one, we added two, and later on when the number of users increased more, we can have three, four, like that. And if it went down, then also you can remove those extra web servers. It can save you money. So this is how it will work. So in that case now, if a request goes to google.com, so the DNS will now return the IP address of the load balancer. Now this load balancer will be responsible for sending the request to the right web server. By right web server, I mean suppose the web server 2 is loaded, so request can go to the web server 1. This is how it can happen. Now there is one problem with this. Suppose you have um, login request. A login request came. It went to this load balancer. It depending on the load, it send it to web server 1. Suppose now this web server 1 will store the user info, okay, and then it will return back the response back. Okay, that user has logged in. Now, when the subsequent request comes, and in that case, suppose load balancer send it to the web server 2. Now, web server 2 doesn't know anything about that user. It doesn't have that info because it was saved in web server 1. So, web server 2 will say that this is not an authenticated request. So how do we solve this problem? So one way is we can have sticky sessions on the load balancer, and this sticky sessions, through this we can control to which web server the request should go. So the first request which came from user 1 and that was a login request. So we know it went to web server 1. So all the subsequent requests we can control that it should go to the web server 1 only. This is stateful architecture, but this is not a very good solution and it's not also very not scalable. So other way is we can go to the stateless architecture. And what happens here is, suppose a login request comes and it goes to web server 1. So user session info, we will store it in a separate DB. I have chosen Redis over here. You can choose other as well. So user session is now getting stored in Redis. Now the subsequent request, if it comes and even if it goes to the web server 2, it can load that user session info from that Redis and then it can find that the user is authenticated and it can work. Okay, so this is how we can achieve this using stateless architecture. So now we have learned how do we scale the web servers or the web tier. Let's now focus on the database. Maybe the number of users increased and accordingly you have increased the number of web servers. But the request which is coming to the database is too much. So even if you scale this web tier and if there are so much requests which is coming to the database and it is not able to handle this, still your website will be slow. So how do we do that? How do we manage that? One way is we can use the master slave approach. What we do here is we have a master DB where all the writes will happen. If anything a user wants to update, it will go to this master DB. And in the background, the replication will happen. There will be one arrow here as well. So all these DB, these are slave DBs and all the replications happens there and that happens in the background. So if a request come to write some data, the master DB will get updated and then in the background all these will subsequently get updated, right? So if a read request come, we can say, okay, web server, go read from this DB or read from this DB. Depending on the load, we can direct it to the right DB. So in this way, now we are able to manage so much read requests which is coming to the database also. So that is also so this is a very good solution. But you can see one problem here is maybe a request come, a write happened to the master DB, and at the same time another request came and it read from this DB before the new data was being replicated to this DB. So this will return the old data. Okay, so is this a problem? No. If you consider in most of the application, this wouldn't be a problem. But yeah, for some system like a banking system, this is very important. Data needs to be updated. We can't return old data in such cases. So we have to, what we have to do, unless and until all the replications happens, we have to block all the read. But in most of the applications, for example, see you have a social media application and your friend posted some Instagram reels and it went to this DB, it got written to this master DB, but it did not got replicated to this slave DB. So what will happen? Maybe you opened your Instagram and it read from this DB and you're not able to see that latest post. So it is fine actually. There could be 4-5 seconds delay that is acceptable in most of the applications. So depending on the use case, you have to design your system in such manner. So now we have covered this master slave DB approach. Let's talk about another technique which is known as sharding. So here what I explained is that if there are so many read requests or maybe so many write requests, how do we handle that? But let's consider a case where your user database grew so much. Initially it was 1 TB and one database was sufficient to store that information. But later on you have 2 TB, 3 TB, so much data which needs to be stored. What do we do here? Again, we have two options. First is vertical scaling, scaling up. We make this TB, if it was 1 TB, we can make it 2 TB, 4 TB like that. Or the second option is horizontal scaling. In horizontal scaling, we distributes the data among different databases. So what we can have maybe 4 databases. Or you can have 5, 6 depending on the use case, and we are going to distribute all the data. Some data will be stored here, some here, and so on. So this is how we can solve this problem. But again, this creates a new problem. What problem? Now every time a request comes from the web server, it needs to know which database it needs to read. Okay, maybe web server 1, okay, there are 2 TBs here, suppose, okay, 2 TB2, and it wants to get some user info, and that user info is stored in this DB, and it went ahead and read from this DB. It won't get that data, right? So how do we manage that? So there are a lot of techniques. One simple technique is, based on the user ID, we can map maybe all the user ID which follows these pattern. We store in DB0. Other one we store in DB2, DB3, like that. So when a request comes from a web server, it through the user ID, it can know which database it needs to look up. Correct. So this is a kind it can solve the problem, but there are cons to this as well. What happens if we increase the database or some database went it down? How will this work? Now, we will have to change this. If we have 5 TB databases, we'll have to do user ID modulus 5, and then we will have to distribute the database among different. So there are other problems as well with this approach, and we have something like consistent hashing, but I'm not going to cover in this video. But there are different ways to mitigate that, right? And this master slave, again, we can have this here as well. This master slave we can have for db0, we can have one master db, and then we can have multiple slave dbs here, right? So coming to the end of this video, I have covered how do we scale up web tier or database tier. We have other options as well. We have cache, we have CDNs, which depending on the users, we can use that as well. But so the video is not too long, I will cover that in some other video. Thank you.